Hello, my name is Brody Castle, and I'm proposing a method of limiting the impact of electrical operational costs on the economy and environment through modernising the electric train system here in Queensland, Australia. Throughout this research project, I'll be investigating the resources required and capabilities of harnessing photovoltaic energy for effectively and efficiently powering trains here in Australia. The hot, sun-stricken land of Queensland holds some of the highest potentials for harnessing solar power in the world, giving the country enormous potential by being able to revolutionise the transit industry. This industry is currently dominated by electric trains, which have the capability to move all year round through every condition. These electric trains come at a high economic cost though, demanding over $1.4 billion in operational cost annually. As the availability of coal and other natural resources diminishes from human consumption, these electric trains are only going to require more operational and maintenance costs. The project I am proposing is expected to minimise these economic blows and completely change the way that rail companies within Australia supply and deliver electricity to the train network through promoting a clean, renewable method of public transit. I'll be achieving this through the research and implementation of a solar system to the top side of commercial passenger trains. Although the country of India and an instance of a privately owned diesel-electric solar train in Byron Bay have been developed, there has not yet been a significant breakthrough into research in the Australian market by a commercial company. Through the research and implementation of solar technologies to trains, impacts on the environment through typical electricity supply and delivery will be significantly decreased. This will not only positively impact the Australian government funding public transport, but also the customers of the rail services through the reduction in train fares and peace of mind knowing that they are being environmentally friendly. Developing the design for the solar system is to happen in 5 main steps. First is the research and theorization of the project, where a group decides on the best solutions for the company from a business standpoint and specifies goals and subsets to reach throughout development. Next, the project is then taken to the local communities and governments, generating funding and support from the communities through positive advertisement campaigns and local events. The creation of a prototype is then to be developed and tested with the results publicised for positive publicity, and then the implementation of the final model into commercial trains ready for the launch of the product. The standard model of trains in use in Queensland are approximately 145 metres in length, with tracks which span the total combined length of over 6,500 kilometres. Across urban and intra-urban areas of Queensland, there are currently a total of 222 passenger trains operating daily. To achieve solar effective conversion across the fleet, trains must be equipped with the most efficient solar technology available. Modern solar panels, like the LG Neon H solar panel, as shown to the right of this slide, can produce up to 385 watts of power in standard operating conditions, achieving 20.9% efficiency in solar conversion. These LG panels offer superior servicing capabilities through using a plug-and-play adaptation, where if one panel is removed or damaged, the entire system will not be out of commission. Through further research and implementation of logistics into the project, solar energy is to be integrated into the current power system, rather than replacing and abolishing the current system. Achieving this integration will allow trains to operate normally throughout periods of low light, such as in nighttime or in tunnels. Upon the completion of this project, the solar implementation into the rail network will supply a surplus of 25 kilowatts of energy required to power all trains along the network. It will reduce emissions from coal refinement and burning, while also taking crucial steps forward within society to achieving the 2030 goal of 35% decrease in carbon offsetting. To complete this project, the entire train fleet within Queensland must be equipped with some 65 total panels per roof. Through inquiries in local solar suppliers in Queensland, it was found that the average LG panel, as shown in the previous slides, cost approximately $300 per panel at wholesale pricing, requiring approximately $22,000 per train, or an investment of $4.4 million to acquire these panels for all electric trains. As well as funding, Australian local and federal governments must show commitment to this project if Australia is to preserve its natural resources and beauty. Australia has an abundance of constant sunlight available, which as a country, if we are to progress in clean, renewable energy adaptations, we must begin researching and developing products which further harness this into usable electricity. Investing into this solar electric research gap is vital for Australia in a period where natural resources are becoming more sought after and expensive. Thank you for listening, and I hope to speak further soon to commence research.